Go.
How's it going, everybody? Today we're going to be covering another group of dinosaurs for my live streams, which have turned into a series on dinosaurs. Before we do, feel free to come on into the Headwaters Science Center. We're open 7 days a week. 6 days we are open 9:30 to 5, and on Sunday we're open 1 to 5. So the dinosaurs we are talking about today are the Ankylosaurians, which is a group of dinosaurs that probably everyone's passingly familiar with. Probably everyone saw an ankylosaur at some point as a little kid going through books of dinosaurs. They're a quite distinctive group of animals, being probably one of the most heavily, if not the most heavily armored animals to ever exist. And we're going to go into some of the things that make them rather unique, and one of my favorite groups of dinosaurs as an adult. So the first thing about them is they were around from the mid-Jurassic to the end of the Cretaceous. You'll notice a lot of dinosaurs we tend to think of as Cretaceous have their roots evolutionarily back in the Jurassic, when the ecosystem was a little bit different. So they are an ornithischian dinosaur, bird-hip dinosaurs. So this is a different group than the dromaeosaurs, who are confusingly saurischians, lizard-hip dinosaurs. And they are found on all continents that we have found fossils on from the Cretaceous. There are ankylosaurs from Cretaceous Antarctica, Australia, Asia, Europe, North and South America, and Africa. These were remarkably successful animals worldwide during the Cretaceous. So they can be divided into 2 to 3 families, and there's a serious debate on whether one of those is just a subgroup of another. And the 2 main families we're going to go over today are the ones that we definitively accept as existing. So those would be the Ankylosaurs and the Nodosaurs. And the key difference between Ankylosaurs and Nodosaurs is in their tails, but also extends to other parts of the body. If you can potentially zoom in really quick on this diagram here. So this diagram here is the difference between the 2 tails. So Ankylosaurs are the ones you probably are most familiar with. They had a large club at the end of their tail, which we pretty definitively know was used as a defensive mechanism. Nodosaurs are a little bit less well known, but I think it's kind of interesting. They often had a series of spikes and plates on the sides of their tails, but no large club, although their tails tended to have a firmer rod of bone near the end, making it a little bit more like a baseball bat, where the Ankylosaur's tail is a little bit more like a flail, a little bit more bendy, more flexible. In general, Nodosaurs also tended towards smaller body size. By no means small animals, but not nearly as large as some of the truly massive Ankylosaurs were. And the other thing is, Ankylosaurs tended to have fewer spike projections on their body, where Nodosaurs tended to be a little bit spikier, which made sense. If you're a little bit smaller, a little bit more in, mouthful size of an animal for some of the massive predators, it pays to be a little bit less comfortable in the mouth. These animals did have some of the smallest brains to body size ratios of any dinosaurs, only having a better brain to body ratio than sauropods, the largest terrestrial living things ever. These animals were probably not geniuses like our last group of dinosaurs we went over, the dromaeosaurs, kind of the opposite end of the intellectual spectrum here.
Are these the ones that had the like nerve clusters, like mini brains?
No, the nerve cluster hypothesis is also one that hasn't aged well with fossil evidence, and we can get into that when we get into sauropods.
Okay.
So they are possible relatives to stegosaurs of the Jurassic, which are going to be a whole nother live stream. So the largest Ankylosaurians were in the Ankylosaur family. That's stuff like Ankylosaurus and Eucephalus. And they got to about 33 feet and upwards of 4 tons. Just for reference, a ton, in the way I'm using it for this term, is 2,000 pounds. So 4 tons is quite a lot of weight. And the smallest confirmed Ankylosaurs, or Nodosaurs, we're unsure which group it belonged to, was at about 6 feet long. You'd expect probably not as extreme a weight as I'm about to list. And the smallest one was 700 pounds.
I mean, like, 4 tons.
Is a lot.
That's like an armored personnel carrier or something.
These animals are often called living tanks.
Yeah.
You'll notice these animals will not be, some of them not being as massive as animals even we have today, A relatively elephant-sized Ankylosaur would still massively dwarf it in weight. But
Just
yeah,
because of all the heavy plates and stuff?
yeah, so these animals were herbivores. You may have been wondering, well, if it's that armored, is it a herbivore, carnivore? Animals with a lot of armor like that tend to be herbivores because they're not needing to be as fast, they're not needing to be as nimble. It pays a bit more as a herbivore to be tougher, to be harder to do damage to. And we've got some drawings up here. One was made by me, and these other 3 were drawn by some of our great volunteers. We got the great Ankylosaurus name.
It's by Ellie.
Well, we all made serious handwriting typos while doing this. It was a very fun one.
Ankle sauce.
Yeah, and Ankylosaurians, in general, we forgot to go over the name of the group. It means fused or hard lizard, which, given the amount of plating on these animals, shouldn't be surprising. So these animals, as I said, were heavily armored and possessing everything from scutes, nodules, which are made of bone, plates, which are large bones in their body, osteoderms, which are bones inlaid into the skin, and true scales, and hexagonal sort of rectangular scales. And they were pretty big herbivores, being roughly equivalent to something like you would see today, like a rhinoceros. They were a browsing animal, not a grazing animal, and today I wanted to go over actually the difference between browsing and grazing. Browsing animals are herbivores, just like grazing animals, but browsing animals do not eat ground-growing plants like grasses and mosses. Browsing animals eat stuff like shrubs, the leaves on plants, bark off of trees, and high-growing flowers and other leaves off of taller plants. And the reason I bring this up is a lot of the herbivores that we're going to go over when we go over dinosaurs tend to be browsers. And that's simply because grasses did not yet evolve during the Cretaceous. Grass is a relatively recent plant in evolutionary terms. While there were ground-living plants at the time,
Reeds and stuff, right?
there were some reeds and stuff, but they were not as common, so they didn't make up as big a part of these animals' diets. So almost all dinosaurs would have been browsers, which is why if you ever watch Jurassic Park and you see these dinosaurs grazing grass, something they wouldn't actually biologically have been really set up for, and probably would not have the digestive system to process grass. It's something that, if you look at mammals, they have rather elaborate digestive systems for solving the problem of eating grass, which we might get into in a future video, because it's rather interesting.
Ruminants and stuff.
So the other question is, why all of this very heavy armor on an animal? They lived around some pretty heavy-duty predators. Evolution's often described as an arm race, and in a lot of ways that is a good way to look at it, between predators and prey. And I would not exclude plants from that either. Plants can get pretty nasty when they want to not be eaten.
Plants are kind of, yeah,
The
you
defining-
don't think about them as prey, but they are.
They're prey for these guys.
Yeah.
So these dinosaurs, just to go over parts of them that were armored, their skin with the nodules and osteoderms and regular scales. Obviously their backs had the plates, scutes, and large spikes in the case of the Nodosaurs. Their eyelids, in fact, were armored, and that has led to these dinosaurs preserving extremely well in the fossil record. When you find an ankylosaur, you typically find a large chunk of the animal, which is why we know so much about how these animals' bodies looked. And in fact, they preserve so well, being large, bony creatures, we often are able to find specimens preserved well enough in sediments where we can actually tell very small details about them. So Borealopelta is probably one of my favorite dinosaurs because it's one of the most complete fossils we've ever found, all the way down to the skin. And on a cellular level, it was preserved in oceanic silt as it died and washed out to sea. And we actually found preserved melanocytes, which we went over last live stream on dinosaurs, which told us actually the color of this dinosaur by examining those fossilized melanosomes and looking at modern ones and other animals that we know the color of. So we know that most ankylosaurs were likely reddish-brown on the top, so that back half,
Like you can see on that picture, yeah.
and then lighter tan on their bellies, meaning they were countershaded. And countershaded is a method of camouflage which takes advantage of how light coming from the sun interacts with objects vertically, which would hopefully help to make these animals' silhouettes a little bit less visible for the predators, as these animals, weighing the excessive weights they did, were not fast. Their top speeds are estimated in the single digits, with 6 miles an hour being a relatively generous speed. And actually going over that is, James just said that'd be like a sprint. So fun thing is they would actually be animals that wouldn't be capable of true running.
Yeah, I suppose.
Basically, there aren't not all animals can truly run. Running, defined scientifically, is being able to get multiple feet off the ground at once. So animals you may recognize as not being truly able to run are elephants, who basically fast walk everywhere.
Yeah.
And speed walk everywhere. And these animals would have been in that group too of, they aren't running anywhere, but they're gonna do a little hustle with a walk.
The idea being for a human, if you're running, it means at some point during your run,
both feet
are off the ground, yeah.
And in a case of an animal like a rhino, which can run, at certain points of their run, rhinos have all of their feet off the ground.
Yeah.
So, with these animals, they're one of my favorite ones because we know so much about them. That animal, Borealopelta, was also found with its stomach contents fossilized, so we know kind of the vegetation they were eating, which leads to these being a relatively well-understood animal. Well, we don't know exactly how they evolved, as their ancestors don't preserve as well due to not having the excessive amount of bony plates and hard parts, similar to how we talked about turtles' ancestors not preserving well due to lacking the shell initially. Once we're actually studying these animals, it's really easy to have a question to go, how did this body part work? Well, we have a lot of them, so we can really test that. It's easy to make castings and replicas and models of these animals for examining biomechanics because we have so much of their skeletons and we have so many different species that we are able to really compare them and see how they all may have interacted and
Can you define biomechanics?
Biomechanics is the physical way your body moves, like how your elbow joint actually moves mechanically.
The machinery of life.
The physical machinery of how your body works, in the terms of like your joints, how you maintain blood pressure. And these animals are, again, kind of a perfect example. And we have, in life's history, we have yet to have another group of animals really go this far and become so armored and so defensively oriented.
Are these guys about as extreme as it gets?
They're about as extreme as we've ever seen. Yeah. Obviously, you don't want to say they're as extreme as you can get, because in the future we don't know what may evolve.
Of course, but what we know, of what we know,
this is, if you want to be armored and just really hard to bite and kill, Ankylosaurs really did it, because these are animals that were sharing their environment with predators like tyrannosaurs, which were carnivorous dinosaurs who evolved incredibly strong jaws specifically for tough prey, and there's very good evidence these animals were not often preyed upon. We will find Ankylosaur fossils with some marks as if they may have been bitten, but clearly the Ankylosaur actually survived the encounter a lot better than probably the other animal. We found tyrannosaurs with pretty messed up femurs.
Yeah, it seems like those clubs could really do some damage to a predator.
The clubs and those tails, because we tend to think of the clubs being as probably the more dangerous one because it's got that big mass. But those tails, remember, they were not the same structure. They were a little bit stiffer, so it was like a 2x4.
You get whamped by the whole thing like a bat.
Yeah, it's more solid, like getting hit with a 2x4 versus getting hit with like a sock full of quarters. You don't want to get hit by either, but
you especially don't want to get hit by
the baseball
bat.
Yeah.
That's really bad.
But yeah, so we do find some predatory dinosaurs with injuries that were fatal. That probably the only thing in the ecosystem doing that kind of damage was an Ankylosaur or a Nodosaur tail. They were tough animals and probably often avoided.
Yeah.
The other thing about them is they were actually a little bit more social than we thought. We found some foot tracks recently, and there were, of the same age, at the same time, mud tracks of multiple Ankylosaurs walking together.
Like herds?
Possibly not herds, but in small groups
like
is pretty well. Sort of like how rhinos will occasionally walk around in like 4 or 5.
Yeah.
So not quite a herd or a pack, but a decent association of individuals.
a social group at the very least.
Yeah. And these animals were related to birds and crocodilians, which are semi-social animals themselves, so it's reasonable to assume most dinosaurs were semi-social. Solitary would have been probably a little bit rarer, actually.
Do we think that these little groups of ankylosaurs, would they be related?
Potentially it could be hatchling groups, it could be groups of the same age, it could be groups of the females hanging out together, the males hanging out together. Like today with elephants, you'll often see bachelor herds of elephants where the males hang out together because it's a little bit safer for everyone if they all hang out.
Yeah,
whereas
and the females, especially when they're rearing calves, they don't want...
Which for parental care for dinosaurs is hard to speculate on because from what we know, there's a wide gambit of very good parenting from stuff like tyrannosaurs and hadrosaurs down to the... protection and stuff, right? Down to the you're on your own method of sauropods, which is much like sea turtles today, which is the, if you lay a bunch of eggs and let them all hatch, someone's gonna make it. And Ankylosaurus, that's the one part about them that we don't have a lot of evidence on. Although these animals have brought up the question is, physically, how did they mate? Given all of this armor and these large tails and plating. And this is a general conundrum with dinosaurs overall, is biomechanics of mating can get a bit confusing when you get to a certain size and a certain shape. And a lot of dinosaurs are in that size and shape of, mechanically, this has got to be uncomfortable to a certain degree. This can't be that fun.
Well, and the other thing is, I mean, they're egg layers, right?
Most dinosaurs would have probably been egg layers. We don't know if any may have been ovoviviparous, but we're reasonably sure that none of them were giving birth to true live young.
So, would they have had cloacas?
Most dinosaurs, we're reasonably sure, and with these guys, we're actually very sure they had a cloaca. We have got a few impressions. So they had that universal exit. Birds and reptiles have a different setup with how they excrete waste and where reproductive organs are. It's typically a universal opening called a cloaca. But yeah, so also the other one with rearing young, we're not sure exactly. But the one thing with dinosaurs is those big, massive ankylosaurs at 33 feet and 4 tons probably hatched from eggs not all that large. The largest dinosaur eggs were sauropod eggs, which only would have been about a soccer ball size. These guys' eggs probably wouldn't have actually been that massive, but the advantage of egg laying is the parent animal does not have to carry that young all the way to full development where it's able to survive on its own. They can lay that egg, either nest it or stash it somewhere, and let it hatch out at a smaller size than it can grow. And it's a disadvantage mammals have for getting truly massive, is because we give birth to live young, that can lead to excessively long pregnancies in large mammals. Elephants are pregnant for near 2 years. Dinosaurs got to sidestep the 2-year pregnancy issue, or for a sauropod, if they were a mammal, likely would be a multi-year pregnancy of probably nearing 10 years. By laying eggs and letting these animals hatch at smaller sizes and balloon out in size from there. But yeah.
But the trade-off, I suppose, is that if you are born tiny as a little ankylosaur,
you're a bit more vulnerable.
Very vulnerable, yeah. And
that is the trade-off for egg laying. Egg laying animals hatch at these smaller sizes, so for a portion of their life, they're a lot smaller than the adults. A baby ankylosaur probably would be like less than the length of my arm, which is not a great size to be in an ecosystem like the Cretaceous, which was very heavy with predators. But being heavily armored really does help with that. So even the small ankylosaurs would have had a lot of armor. We actually do have a few... We have a few smaller Ankylosaur fossils, which may be either smaller species or young. It's not super conclusive. But if they were young, they were armored from a very young age. Those plates are probably one of the things that developed very early, if not in the egg.
Really?
Yeah, so that...
They come out a little soft, but then harden up very quick.
Kind of like a turtle.
Yeah.
They come out a little bit soft, but then within like a day or two, it's ready to be a little bit more defensive.
Yeah.
But yeah. Honestly, one of my favorite dinosaurs, the more I've learned about dinosaurs, and an underrated one.
I really like Ankylosaurus. They've always been like my favorite.
Yeah, one of our coworkers, Ryan, likes to describe them as like peak dinosaur. It's an animal that, like, from a modern perspective, there's really no conception of this. There's no good equivalent to this animal today.
Maybe a rhino.
Maybe a rhino at closest, but it's definitely an animal that I have trouble finding a modern counterpart because it's so large, so heavily armored. And just like the tail club, there's not a lot like it today.
Were their scales keratin?
They probably did have both primary or secondary scales, more leaning on probably secondary scales, like we went over with turtles and alligators quite a while ago.
So primary being bone.
Primary being keratin,
then
secondary
secondary
being bone and keratin. But yeah, these guys probably would have had more secondary scales, probably a few primary, but
So
it's
they're actually
likely
growing bone out of their backs.
they're growing bone over and in their backs. The osteoderms that we went over are little things of bone which make it so if a predator bites the softer parts of these animals, they still might hit their tooth on a hard thing of bone, which might save this animal a little bit of damage. Again, these animals also were relatively low to the ground. Even those large ones would have been maybe 6 feet at the shoulder. I'm about 6 feet tall. So for an animal that weighs 4 tons to only be about that high off the ground, they were eating low browsing vegetation. So that meant they kept their belly close to the ground. And that meant that these larger carnivores, like a Tyrannosaurus rex, which is 40 feet long, but 15 feet tall, is going to have trouble getting their massive head under it to get at the belly.
Yeah.
So that's another way these animals evolved to sort of prevent predation.
Yeah, they really are like tanks. Like
It's a biological tank.
Yeah, it's really interesting. They're just low to the ground, heavily armored, slow, and they just rely entirely on that mass and armor, it
It's
seems.
all being big and tough to kill, basically making it really inconvenient and hoping that a predator looks at this and goes,
Eh.
I'll eat something else. I'll take my chances on something else.
Yeah.
And remembering some of the dinosaurs we've gone over, those something else's weren't exactly pushovers. These guys were just worse to deal with.
Yeah, it's like porcupines, kind of.
It is actually, yeah, you know, James just said, it's very much like porcupines, being physically tough to just do anything to. That's a good way to look at it. It's not the same strategy, but it's a really equivalent one.
Yeah, right. It's similar. Maybe that's a good modern equivalent, even though it's so much smaller.
I think it is a good one.
Yeah.
But yeah, so that's kind of all I've got for this one today. My next live stream will be on another type of dinosaur. And I'm thinking of just getting into it every other week, just doing carnivore, herbivore. But yeah, thank you.